Electrolytic cell. Electrolytic cell is a device which can give us constant and continuous current. This current is DC current. Now, the electrolytic cell is also known as volcanic cell or primary cell. Primary cell means that it cannot be recharged, whereas secondary cell, that is the electrical battery, that can be recharged. So the electrolytic cell is not a secondary cell, it is a primary cell which cannot be recharged. Such type of cell, they convert chemical energy into electrical energy. Now we have this is the pot in which electrolyte is filled. Now electrolyte we have taken is H2SO4 is electrolyte. One electrode is made from the copper and another of the zinc. Zinc being negative and copper being positive. Now the electrolyte is dilute H2SO4. Dilute H2SO4 will be converted into 2H plus SO4 double minus. So this is the positive ion, this is the SO4 will go to the zinc, it will react with the zinc double plus and zinc sulfate is formed. So zinc will be dissolved here. Now due to this positive charge of zinc, the H plus are repelled and H plus will come to here. So here the negative charge of the SO4 is given to the zinc. So there will be excess of electron here in the zinc and there will be excess of positive charge here due to H plus on the copper. So copper works as a positive P and zinc behaves like a negative N, or we can say the copper is anode and zinc is cathode. So in the copper or P type, there is an excess of there is an excess of positive charge, or there is a deficiency of electron, or the number of electrons will be less. Whereas in the zinc, which is negative or cathode, there is an excess of electron. So now we will consider the potential between the copper plate and the electrolyte. If we consider a point A very close to the copper plate, then the potential difference between the copper plate and A is V plus. Similarly, at the negative end or at the negative electrode, we consider a point B, and the potential difference between zinc electrode and P point is minus V. So the potential difference between P and N, or anode or cathode, will be equal to VA, which is positive, and VB, which is negative, with the negative sign. The value of VA, the value of potential difference between copper and A point is point plus 0.46 volt, and the potential difference between the zinc and B point, it is equal to minus 0.64. So the potential difference between the anode and cathode will be equal to the EMF of the cell, because cell is in the open circuit, no current is passing through it. So cell is in the open circuit. When the cell is open circuit, the potential difference between the anode and cathode, or positive terminal or negative terminal, that is the EMF. So EMF will be equal to VA positive minus VB negative. So it will be VA plus VB. Now if we substitute the value of V and VB, then this will be equal to plus 0.46 minus 0.064. So this will be equal to 1.08. So 1.08 is the potential difference between the anode and cathode, or positive terminal and negative, and this will be the EMF of the cell. The EMF of cell does not depend upon the shape and size of the electrode. It only depends upon the material, and here we have taken copper and zinc material, and the potential difference between anode and cathode when the electrolyte cell is in open circuit, means no current is flowing, that will be EMF, and EMF will be equal to 1.08 volt. Now we know that we are having two cells. One type, generally we are having two cells. One is the Daniell cell. For the Daniell cell, we have copper as positive and zinc as. So the EMF of Daniell cell is 1.08. Another, we take the Lagrange cell. In the Lagrange cell, we have here ammonium chloride. Here we have a carbon rod, and here we will have a zinc rod. And the EMF of that Lagrange cell is nearly equal to 1.5 volt. Now if we connect the positive and negative electrode with a resistance, so current will flow from P to N outside and N to P inside. When the current is flowing through the electrolyte, it will offer a resistance, because the presence of the ions of the electrolyte, there will be obstruction in the flow of charge or flow of the charge carriers. Then the resistance is observed, and that resistance is internal resistance. So internal resistance of a cell cannot be equal to 0. So internal resistance of the cell is due to the obstruction of charge carriers, which are electron or positive charge inside the liquid. Now what is the terminal velocity, terminal potential? Now the potential difference between P and N when they are in open circuit means no current is flowing, they are not connected, then the potential difference between the positive electrode and negative electrode is EMF. But if we connect it by through a resistance, so current will flow from P to N and N to N inside, then there will be a fall of potential. That potential will depend upon the current, and the fall of potential will be equal to small I, the current passing through, into internal resistance. So now the potential difference between the positive and negative is terminal potential, and terminal potential is naturally less than EMF. So the terminal potential V will be equal to EMF E minus I into R. I is the current and R is the internal resistance of the cell. So if R is external resistance connected here, then current passing through it, then the V will be equal to I into R, where capital R is the resistance which is externally connected. So the potential difference between P and L will be equal to I into R. So we can write EMF epsilon or E is equal to E is equal to, right here also we can write V is equal to E minus IR and V is equal to R equal to IR. So we can write epsilon minus I into R is equal to V. So E into V, we can decide and we can decide. So E minus V, this is equal to I into R. So I is equal to V but R. I will be equal to V but R. So we substitute here. Then E minus V will be equal to V but R into R. So we can find the value of small r within the internal distance will be equal to E minus V but V into capital R, or we can also write that this is equal to E upon V minus 1 multiplied by the capital R. So here R is the internal resistance. Now internal resistance of cell is not a constant quantity. It varies and it depends upon many factors. Number one factor, that it depends upon the distance with the electron. If we increase the distance with the electrode, then what will happen? Then the length of path will increase. So the internal resistance will increase. Second thing, if we increase the area of cross section of positive electrode, that is copper, where hydrogen ions give the charge, so that should be more. So if area of cross section of the anode is more, then the resistance will be less. So as the area increases, the internal resistance decreases. Next, it will also depend upon the concentration of the solution. If the solution, which is the electrolyte, is concentrated, then it will offer more resistance. So the resistance, internal resistance of the cell will increase with the concentration. Now, next point, the internal resistance will also depend upon the amount of current drawn from the source. If the amount of the current drawn is more, then internal resistance will increase. Internal resistance also depend upon the temperature. So these factors are 5 factors on which the resistance, internal resistance of the cell depends. Number one, it will depend upon the distance between the electrode. If the distance between the electrode is more, resistance will be more. Second, if depends upon, it is inversely proportional to the area of cross section of the anode. If the area of cross section is more, then internal resistance will be less. It will depend upon the concentration of electrolyte solution. If the concentration is more ions are present. When more ions are present, then the internal resistance will be more. And it will depend upon the temperature. It will also depend upon the current which we are drawing it. If the more current is drawing, the internal resistance will move. So in this way we can say the internal resistance of cell is not constant, and this thing we will verify when we take the chapter potentiometer, in which we will find the internal resistance, and internal resistance of the cell varies as we vary the resistance here. So by varying resistance, what will happen? If we vary the resistance, means we are varying the current, because EMF is constant. So if we increase the resistance here, then current will be less. So there will be effect of this resistance or the current on the internal resistance of the cell. Combination of cell. As we have earlier dealt with the combinations of the resistance, and resistance can be connected in series as well as parallel. Similar to that, we have a combination of cell, the cell in series combination and cell in parallel combination. For the series combination, if this is the positive electrode, this is the negative electrode, another cell, This is the positive and negative answer. So the negative terminal of first cell is connected to positive terminal of the next cell. The negative terminal of next cell, means second cell, is connected to the positive terminal of the next cell, that is the third cell. So this end will be negative and this will be end will be positive. So such type of combination is known as series combination. As in the resistance, there is only one way of passing the current. Here also there is only one way of passing current. Now the EMF here in the series circuit, EMF will be move. There will be only one path for the current. The total internal resistances are added, so it will be more, and here the current will be in this circuit will be less because of the internal resistances. So for the sake of simplicity, we consider two cells. One cell E1 and resistance R1, and this is E2 resistance R2. Here this point is A, here point is B, and here this point is C. Now the potential difference between the A and B, the current will flow from this, means the potential difference of A is more than that of B potential. So VA minus V will be equal to the EMF F1 minus internal resistance R1 into I. So VA minus VB is equal to epsilon 1 minus I into R1. Between B and C point, current is flowing also in the same direction. So the potential of VB is more than VC. So VB minus VC will be equal to E2 minus I into R2. So if we sum it, this VB will be cancelled. VA minus VC means the potential difference between A and C. VA minus VC will be equal to epsilon 1 plus epsilon 2 minus I into R1 plus R2. So here we can write VAC, VA minus VC, we write VAC will be equal to E1 plus E2, we can write E equivalent minus I current into I equivalent, where E equivalent is equal to the sum of E1 plus E2. R equivalent is sum of internal resistance R1 plus R2. So we can, this circuit can be replaced by this circuit. Its resistance is R equivalent, the total EMF is E equivalent, and we connected externally by resistance R. Then what will be the current? The total current will be equal to total EMF but a total resistance. So the current will be equal to total EMF but a total resistance. Total resistance will be equal to external resistance R plus internal resistance, sum of the internal R equivalent. So here if we have, here we are considering only two cells. If we have a n cell, then E equivalent will be equal to E1 plus E2 plus E3 plus En. So it will be total EMF will be equal to algebraic sum of all the EMF of the individual cells. Similarly, the R equivalent, the equivalent resistance will be equal to sum of R1 plus R2 plus R3 plus R. So it will be equal to summation of Ri, R1 plus R2 plus I. So the current in this circuit, as I told you earlier, the current in circuit will be equal to total EMF divided by external resistance R plus R equivalent. So this will be equal to summation of EI bata R plus summation of Ri. Now in the case if there are the n cells and we consider the n cell are of equal EMF, then the total current will be equal to summation of EI will be equal to n into E divided by R capital R plus the total R equivalent will be equal to N into R. So current will be equal to N into epsilon divided by capital R plus I. So this will be the total current in the circuit. Now if capital R is more than small r, then we neglected small r, so current will be equal to N divided by R into E. Now if NR is more than R, then we will neglect it, so NN will cancel, then the current will be equal to epsilon bata R, that is equal to the epsilon R is the current due to the one cell. So in this way we can discuss the series combination. Now for the parallel combination. In parallel combination, as we have done for the resistances, we can parallel combination of cell. In the parallel combination of cell, all the positive electrodes are connected at one point and all the negative electrodes are connected at the next point. So this will be the one positive end and this will be negative end. In parallel combinations, the current will be high. The total current will be equal to the current in this cell, current in this cell, current in this. So here the current will be high. Now the internal resistance, their resistances are parallel, so the total internal resistance will be also less in this connection. So for the sake of convenience, we consider only two cells. One cells E1 and E2, internal cells R1 and R2, they are connected with parallel. Positive is connected to positive, negative, this end is connected to here between, and if the voltage between these 2 points is V, I is current flowing through this, then the I1 current will flow this and I2 will current flow from this cell. So total current will be equal to sum of the current in this cell and sum of the, so total I will be equal to I1 plus I2. So total current here will be I1 plus I2. Then what will be the, we will find the value of I1 and I2. So V will be equal to, terminal voltage V will be equal to epsilon 1 minus current I1 into R1. Here also the terminal voltage V will be equal to epsilon 2 minus I2 into R2. So V will be equal to epsilon 2 minus I1, I2, R2 and V is equal to 0. So we can find the value of I will be equal to E1 minus V but R1. I2 will be equal to E2 minus V divided by R2. So total current will be sum of this and we can write total current will be equal to this current plus this current. So it will be equal to E1 by R1 plus E2 by R2 minus V1 by R1 plus 1 by R2. So we take here R1 R2 as the LCM, then I will be equal to E1 R2 plus E2 R1 by R1 R2. Similarly here also minus V R1 plus R2 by R1. Now we put V inside and multiplied by R1 plus R2 divided by R1 R2. Then we can find the value of V from this expression. So V will be equal to, this will be equal to E1 R2 plus E2 R1 divided by, this will cancel. So this divided by R1 plus R2 minus current I. Current will be equal to R1 plus R2. It will be equal to, here it is product. It was the R1 plus R2. So it will be equal to, I will be equal to R1 into R2 divided by R1 plus R2. So V is equal to, this will be the equivalent EMF minus I into equivalent resistance. So equivalent EMF will be equal to E1 R2 plus E2 R1 divided by R1 plus R2. Similarly, equivalent resistance will be equal to R1 R2 divided by R1 plus R2. So this will be the relations between R equivalent and this. So if this circuit can be reduced by this circuit, instead of two cells, we will have a one cell whose EMF is E equivalent. Instead of this R1 and R2, we will have one resistance, and that is equal to R equivalent. So, and we connect it by a resistance capital R. Then what will be the current? Current will be equal to EMF E equivalent divided by total resistance will be equal to R plus R equivalent. So, current will be equal to E equivalent divided by R plus this. So this will be the current. Now in the case, this we have find for the two cells only. If we have a n cell, and if n cells are of equal EMF, means E1 is equal to E2 plus E3 plus En, and their internal resistance are also equal. R1 is equal to R2 is equal to R3 is equal to Rn. Then E equivalent will be equal to E, and R equivalent will be equal to R divided by N. So the total E will be the same. EMF will be same of the one cell, but the total resistance will be equal to one end of this. So here the resistance will decrease, means current will increase. So here in parallel circuit, current in parallel circuit will be more than current in the series circuit, whereas in the case of series circuit, EMF will be more in series circuit than the EMF of the parallel circuit. This is all about the cell.